Hello everyone, myself I'm Sri Valadiya from Sri Venkateswara College of Engineering, pursuing in third sem CSC. Subject Mathematics. Topic Joint probability distribution for two discrete random variables, expectations, covariance, and correlation and application. Introduction to joint probability distribution. Joint probability distribution describes the likelihood of two discrete random variables occurring simultaneously. It provides a comprehensive overview of the relationship between the variables. Understanding the joint distributions is the fundamental in statistics and the probability theory. Types of a random variables. Here random variables are two types. These are discrete and continuous. In discrete, probability distribution of a discrete random variable, and in continuous, probability distribution of a continuous random variable. Definition of a random variables. A random variable is a numerical outcome of a random phenomenon. Discrete random variables can taken on a countable number of values. Example includes the number of heads in coin flips or the count of dice rolls. Here in discrete variables, the definition is a discrete variable is a numerical variable that can only take on a finite number of distinct values and within a given range. These values are the specific, separate, and can often to be counted, unlike continuous variables. Discrete variables do not allow for the split values and between the two adjacent discrete units, which leads to their finite nature. Example, the number of visits to the doctor. Here, people may having differing frequencies of their health and checkups, but we can have a half or the water checkup. Marital status. A survey may ask you for marital status. You can be single, married, divorced, or widowed, but nothing. Joint probability distribution table. A joint probability distribution can be represented in a table format. Here in the each that cell in the table indicates the probability of a specific outcomes for each a random variable. The sum of all the probabilities in the table must be equal and it should be 1. Marginal probability distribution. In the marginal probability distributions, it can be derived from the joint distribution. These distributions represent the probabilities of each and every variable independently. It also provides the insight into the behavior of each variable without considering the other. Here we can see the expectation of a joint random variables. The expectation or expected value is a measure of the central tendency of the distribution. For any two random variables, the expectation can be calculated using the joint distribution. Here, the expected values of the independent variables can be also computed these separately. Here should be taken the two coins are a disc and you should roll it, and how many outcomes will become, how many heads or tails will be shown. Here we can see. So here is the probability of a mathematical expression of a random variables. Here we can see the covariance of a random variables. Here the covariance measures the how to random the variables change together. A positive covariance indicates that the variable tend to increase together, while negative indicates its opposite. Here the covariance can be calculated using the joint probability distribution. It includes the two formulas for the find out in the covariance of a random variables. Here the covariance of the random variables, you can see the covariance of the two random variables. Here you can see the height and wake up time are uncorrelated, but height and weight are correlated. Here the covariance will be x and y is equal to 0 for the x is equal to height and the y is equal to wake up times. Here covariance x and y is greater than 0 for x is equal to height in the y is equal to weight. Definition. Covariance of x comma y is equal to e of xy equal to e of x minus nu x and y is equal to y minus nu y. Question. If covariance of the x comma y is less than 0 for the two random variables x and y, what would be a scatter plot of the samples from x, y look like? And the question be if we add the arbitrary constant to the random variables x and y, and how does the covariance will be changed. Here we can see the correlation and the coefficient. Here the correlation coefficient mainly standardized that the covariance should be provided say dimensional measures of a relationship strength. It ranges from -1 to +1, indicating that the perfect negative or no or perfect positive correlation, respectively. A correlation can be coefficient of a zero implies no relationship between the variables. Applications of the joint probability distributions. The joint distributions are used in various fields like including the finance, engineering and the social sciences. They mainly help in modeling complex systems where the multiple random variables will interact. Here the applications include the risk assessment, decision making and the predictive modeling. Here the types of probability distribution in machine learning includes the uniform distribution, binomial distribution, Bernoulli distribution, Poisson distribution, normal distribution, t-test distribution and the exponential distribution. Examples. The joint probability distribution. It considers two random variables that the number of rainy days and the number of sunny days in a month. A joint probability distribution can show the probabilities of a different combinations of these outcomes. Analyzing the distribution can provide insight into the weather patterns and their relationships. Random types of random variables, discrete and continuous. Discrete is which is a probability distribution of discrete random variable and the continuous the probability distribution of a continuous random variable. Conclusions. Here the joint probability distribution are essential for understanding the relationship between two discrete random variables and the expectation, covariance and the correlation provide valuable insight into these relationships and the mastery of this concept is crucial for advanced and the statistical and analysis and decision making. Thank you.